Hi friends, welcome. In this channel, we are going to discuss the mechanical engineering questions and answers which are helpful for your interviews, competitive exams, and also you get the revision of concepts. We are trying to cover the maximum concepts by uploading videos regularly. So don't forget to subscribe for the upcoming video notification.
A closed system receives 60 kilojoules of heat, but its internal energy decreases by 30 kilojoules. Then the work done by the system is 90 kilojoules, 30 kilojoules, minus 30 kilojoules, and minus 90 kilojoules. To solve this, as per first law of thermodynamics, we have dq is equal to dw into delta u. So here heat is receiving. Therefore, when the heat is receiving, it is positive sign. Therefore, dq is 60. We have to find the dw, and internal energy decreases by 30 kilojoules. Therefore, it is minus 30. So, work done is equal to 60 plus 30, that is equal to 90 kilojoules. So therefore, answer A is correct answer. If the work done on a closed system is 30 kilojoules per kg and 60 kilojoules per kg, heat is rejected from the system. Its internal energy decreases by, we have four options given. We have to find the correct option out of this. When the work is done on the system, it is negative sign. When work is done by the system, it is positive sign. And for the heat, when heat is transferred into the system, it is positive sign. Heat is transferred by the system, it is negative sign. Here in the given work is done on a closed system, therefore it is minus 30 kilojoules per kg. And heat transfer, heat is rejected, therefore heat is coming out of the system, therefore this is also minus 60 kilojoules per kg. From the first law of thermodynamics, we can write dq is equal to dw plus du. So we want to know the its internal energy, therefore we can write du is equal to dw minus dq. So therefore it is work is minus 30 here and heat is minus 60, minus minus this become plus, so the answer will be 30 kilojoules per kg. Therefore option A is correct option. Increasing the heat transfer to a closed system at constant volume is equal to work transfer, increase in internal energy, increase in enthalpy, increase in Gibbs function. So the for constant volume we have no work done, and we know as per first law of thermodynamics, and here work done is 0. Therefore internal energy is equal to change in internal energy. Heat transfer is equal to change in internal energy. So therefore the option P is correct option. Which one is not a boundary phenomena? Work transfer. Work transfer takes place with a boundary phenomena. If we consider a piston and cylinder arrangement, it is a boundary phenomena. Heat transfer, this is also a boundary phenomena. Mass transfer, obviously, this is also a boundary phenomena. Whereas change in temperature is not a boundary phenomena. Therefore, change of temperature is not a boundary phenomena. In a compression process, 3 kilojoules of mechanical work is supplied to 4 kilojoules of fluid, and 900 joules of heat is rejected. The change in specific internal energy would be. So we have a compression process, and here 3 kilojoules of mechanical work is supplied. So work is done on the system, therefore it is minus 3 kilojoules. So in joules we write it as 3000 joules, and 4 kg of fluid, 900 joules of heat is rejected. Heat rejected is 900 joules. So heat is rejected out of the system. Therefore, this is minus 900 joules, and the mass is 4 kg. Same as like in first law of thermodynamics, dq equal to dw plus delta u or du. We have dq value as minus 900 and work done is 3000 minus 3000, and we have to find the change in internal energy. Therefore 2900 joules. Here work is supplied to 4 kg of fluid. So therefore for each kg, joules per kg we have to find. So joules per kg, this will become 725 joules per kg. Therefore answer D is correct answer. Work done is 0 in constant volume process, pre-expansion process, throttling, all of above. This is a RRB question. Since we have work done is equal to PdV for constant volume process, work done is equal to 0, and for pre-expansion it is again 0, and throttling is 0. Therefore, work done is 0 for all of the above. In pre-expansion process, work done from 1 to 2 is equal to 0. Heat transferred from 1 to 2 is equal to 0. Change in internal energy is equal to 0. All of above. In pre-expansion process, we have work done is 0 and heat transfer is also 0 and change in internal energy is also 0 because we have dq equal to w plus du. So when these two terms become 0, that also means that du is also equal to 0. Therefore, the answer for this question is all of above. Pressure cooker works on isentropic process, isobaric process, isochronic process and isothermal process. Since we have isobaric means at constant pressure, isochoric means constant volume, and isothermal means constant temperature. And pressure cooker is a device where the volume is fixed and heat is transferred. Therefore, it is a isochoric process, that is constant volume process. Therefore, option C is correct answer. The cycle integral of delta Q minus delta W for a process is positive, negative, 0, none of above. For a process, the cycle integral of delta Q minus delta W is always 0 because we are talking about the cycle where heat and work will become equal at the end of the cycle or starting point of the cycle. Therefore, cycle integral for a process is 0. Therefore, answer C is correct answer. Heat transferred to closed stationary system at constant volume is equal to work transfer, increase in internal energy, increase in enthalpy, increase in Gibbs function. Heat transfer for a closed stationary system at constant volume. We have a constant volume here and we have dq is equal to w plus du. So for constant volume system, work done is 0 because volume is constant. There is no work transfer take place. Therefore, this become dq is equal to du. That means heat transfer is equal to change in internal energy. Thermodynamic work is product of two intensive properties, two extensive properties, intensive property and extensive property, none of above. For thermodynamics, work is defined as integration of from one point to second point P dV, where P is pressure and pressure is an intensive property, whereas dV is change in volume, it is an extensive property. Therefore, thermodynamic work is the product of one intensive property and one extensive property. Therefore, answer C is correct answer. The maximum amount of mechanical energy that can be converted into heat in any process depends on temperature difference, that is delta T, depends on quantity, depends on nature of mechanical energy, or is 100%. The question asked is maximum amount of mechanical energy that can be converted. We are converting mechanical energy into heat in any process. Since mechanical energy is high grade energy, whereas heat is low grade energy, there is 100% of conversion of mechanical energy into heat is possible. Therefore, the answer for this is 100%. That means we can convert mechanical energy into heat energy because mechanical energy is a high grade energy whereas heat is a low grade energy. Therefore, 100% conversion is possible. Pre-expansion integration of PdV is applicable for reversible process, frictionless process, quasi-static process, all of above. Therefore, it is a pre-expansion. It is only applicable for reversible process and it is not applicable for frictionless and quasi-static process. Therefore, answer A is correct answer. In a particular process, the specific heat of working fluid comprising a system is given by C equal to 0.2 plus 0.002 T kilojoules per kg Kelvin, where T is absolute temperature in Kelvin. What amount of heat is required to be supplied to this system to raise temperature from 300 Kelvin to 400 Kelvin. We are raising the temperature from 300 Kelvin to 400 Kelvin. That is the limit of integration. We have Q is equal to M Cp delta T, where C is given, that we can write MC delta T. So here the system has to be raised the temperature from 300 to 400 Kelvin. Let's take it as a unit mass. Integration of 300 to 400, and we have C as 0.2 plus 0.002 T and dt. So when we integrate, it will become 0.2 T, because integration of dt is T, and here integration of T is T square by 2, and the condition is 300 degree to 400 degrees. So when we put this, it will become 0.2 into 400 minus 300 plus 0.002 divided by 2 is 0.001, 400 square minus 300 square. So this will give the answer of 90 kilojoules. Since we have taken the unit mass, we can write it as kilojoules per kg. Therefore, answer A is correct answer. The change in enthalpy for a closed system is equal to heat transfer if the reversible process takes place at pressure, temperature, volume, entropy. To heat 3 liters of water initially at 19 degrees Celsius to a temperature of 88 degrees Celsius, what time will required from 0.4 kilowatt electric heater? Assume no heat exchange with surrounding and Cp is equal to 4.187 kilojoules per kg Kelvin. Here we have givens. Mass of water is 3 liters, that we can write 3 kg because it is a water. For water we can write directly 3 liters as 3 kg, and heat supplied to water Q is equal to mCp delta T. We have mass is 3, Cp is given, that is 4.187, and change in temperature, it has to rise for 88 degrees Celsius from 19 degrees. Therefore 88 minus 19 is change in temperature. So this value will become 537.35 kilojoules. Let's T be the time for in seconds. then heat supplied by heater is 0.4 times the T. Therefore, we can write 0.4 T is equal to 537.35 kilojoules. Therefore, time will become 537.35 divided by 0.4, that is equal to 1298. We know T is in seconds. Therefore, this is the answer. State whether heat Q and work W are positive, negative, or zero in each of the following processes. The system considered is given in capital letters. First one, 0.1 kg of gas. Here gas is in capital letters. Therefore, gas is the system contained in a insulated cylinder, expands, moving piston slowly outwards. Here we have to state either Q is positive, W is positive, negative, or 0. Since here Q is 0, since the cylinder is insulated, because when the cylinder is insulated, there is no heat transfer inside the cylinder or outside the cylinder. Work is positive since the system boundary expands. We have a simple thing here. When case of work, when his work is done on the system, it is negative. Work is done by the system, it is positive. In case of heat, heat is transferred into the system is positive. Heat transferred by the system is negative. An electric current flows steadily through a resistor which immersed in a running water. Electric current is flowing steadily through a resistor which is immersed in a running water. Here heat transferred is positive because resistor is losing the heat. Here we have heat transfer by the system is negative and heat transferred into the system is positive. So resistor is getting the heat, therefore it is positive, and work done is negative because work is done on the resistor. 1 kg of air flows adiabatically from the atmosphere into an evacuated bottle through a valve. Here heat transferred is 0 because process is adiabatic. Work is negative because work is done on the system since free air boundary is contracting. A rigid vessel containing steam at temperature of 150 degrees Celsius is left standing in atmosphere which is at temperature of 30 degrees Celsius. Here heat transferred is positive because heat is lost by the steam to atmosphere. Work done is 0 for a rigid vessel because volume remain constant. There is no change in volume.
If you have any questions or comments, text in the comment box, and don't forget to subscribe because subscription is free and also you get the notification of upcoming videos. And please like and share. Thank you.